Look at its temperature range. The temperature range is on the bottom.
So if we look at the temperature on the globe, you can see the equator is about 25 degrees Celsius. Then as you start moving up north, you get into sort of the 20 degrees Celsius, and the green is 15, and the 10 is blue, light blue, and then 5, 0, -2. So where do you think you'd find Med4, since it can grow from 10 degrees to about 27?
Won't answer? They're scared to answer. Somebody answer. Raise your hand. Somebody answer. Raise your hand. What's your answer? Light blue to yellow.
Light blue to yellow, exactly. That's where you find Med4. And how about MIT 9312?
Yeah, equatorial regions, right?
Exactly.
Yellow, orange.
The equator up to like all of the yellow regions, pretty much. Once you start getting to the green, it's too cold for them. Exactly. Now, this is what the ocean is predicted to look like in about 100 years. So what do you think will happen? Where do you think you'll find MIT 9312 in the future?
Raise your hand. I'll give you extra credit. You want to go again, Connor?
Sure.
Okay. He said in most of the ocean.
Most of the ocean. What about the center? What about this region where it's red?
He said it'd be too hot.
Exactly. And what about Med4? Before, its region was sort of here, in the green and the blue. What happens to that region in the future?
It got smaller.
It got smaller.
Yeah, if you guys could raise your hand, it'd be better.
Where did it move?
Where did it move? Raise your hand. Manny. Yeah.
It's the bottom. And also towards the top, right? So further south and further north. Exactly. That's exactly what's predicted to happen by when, you have scientists that model these different things. And so this is a scientific paper that showed that the red region is where it's going to become too hot for MIT 9312 and Med4. And the blue regions are the areas that it will move into. But if you notice, the red regions where it's going to become too hot, those are generally larger than the blue regions, the areas where it can move further north or further south, right? So what do you guys think how might this affect ocean food webs?
Brad? Says that there's going to be migrations of consumers to other regions.
Exactly. What do you think might prevent us from making predictions about what will happen to food webs?
Can you repeat the question?
What sort of things don't we know? Like, what can't we make predictions about?
Come on, serious guys.
Like, so we think that they'll move further north, but what sort of new things might they encounter if they move further north or further south?
It's the same few people. Someone new. Yvette. They're going to what? They're going to be subject to different climates and weather.
Weather, definitely. What types of other organisms might they encounter?
Connor?
They might be able to evolve.
He commented on how they would have to evolve with new habitats.
Exactly. So we also don't know how they might adapt and evolve to warmer temperatures or new environments, right? So we don't know much about evolution rates. We don't know much about sort of the variability of the climates that the and the areas that they move into, how that will affect them. Also, they might come into contact with different consumers or different competitors, different types of phytoplankton. They might come into contact, there's viruses in the ocean that only affect certain types of phytoplankton. They might come into contact with new viruses. So there's lots of stuff that we don't know about how a migration of Prochlorococcus might affect ocean food webs and how they might adapt and what they might be exposed to. So those are the questions that I'm trying to answer. And the way that I go about doing it, I'm going to go through this really quickly because I want to leave some time for questions, is Prochlorococcus is mainly found in the center of the oceans. You actually don't really find it in the coastal regions because it gets, there's too much heavy metals that get washed into the ocean from the land, both pollutants and just natural metals that get washed into the ocean from terrestrial environments that Prochlorococcus, generally, they actually poison Prochlorococcus. So you don't generally find it right by the coast, so you have to go out to the middle of the ocean to study them. So I've gone on 3 ocean cruises so far, on 2 different vessels, the Thomas G. Thompson and the Kilo Moana. One cruise was only for a week, but 2 cruises were each a month long. And I went out for a month in January and a month this past July to try and determine how temperature change might affect Prochlorococcus just by looking at it on a seasonal cycle. So life at sea, it's kind of like summer camp if you've ever been to summer camp. We have sort of certain eating times, we have dorms, we have certain relaxation times. We also have to do safety drills because out in the middle of the ocean, you're a 2-day boat ride from any sort of help. So if something goes wrong, you're sort of stranded. So we have to be prepared for any sort of emergencies that might happen. And when we went out in January, it was very rough. There were 30-foot waves and hurricanes, and the bow of the ship is about 3 stories high, and there's waves crashing over the bow of the ship. The summer was much calmer, but generally it's just very exciting. There's a lot going on there. We also had there's a lot of work that goes on. We also had some fun days. I don't know if you guys had dress-up days in elementary school, but college students tend to be like elementary schoolers in that they like to dress up. So we had an 80s day and a pirate day, but mostly it's a lot of work. So we have this sampler called a CTD, which stands for Conductivity Temperature Depth. And you can see there's all these bottles on it. And what happens with the bottles is we put them into the ocean and leave them open so they fill up with water. And we trigger them to close at different depths. So we can get samples from the different depths to see the different nutrients and chlorophyll and the different types of Prochlorococcus that are there at the different depths. So this is a video of what it's like to sample from the CTD. It's always moving out there in the ocean. You have to be really